Can a new energy vehicle run for 1.2 million kilometers? Lithium batteries are advertised to have a lifespan of 3,000 cycles, and based on the calculation of running over 400 kilometers on a single charge, what is the concept of 1.2 million kilometers? By then, the car would likely have been scrapped, but the battery may still be in good condition. But however, reality is quite different. Hey friends, thanks for joining me. Welcome to the channel. If you're new here, my name is Will. Come for the lithium battery tips and stay for the battery equalization problem. The 3,000 cycle lifespan is laboratory test data for a single battery cell. A car battery consists of at least 100 lithium cells and up to tens of thousands of cells. All these cells need to follow the same effect, which is like the weakest link in a chain. The result is that even with a 1 in 100,000 defect rate for lithium cells, the defect rate for batteries can become 1 in 10 or even higher. The battery pack, which is made of many cells, is divided into more than 100 strings internally. The voltage of these strings must be kept consistent to ensure capacity. However, no two leaves in the world are exactly the same. Although there are multiple layers of monitoring to ensure detectable data consistency, it's difficult to screen out the self-consumption differences of the battery cells. So, how can we solve the voltage difference caused by the self-consumption differences of the battery cells? Therefore, when solving the problem of voltage differences, we need to understand the term equalization, which is to equalize the battery pack. There are two modes of equalization: active equalization and passive equalization. There is a rate for equalizing resistors inside the lithium battery BMS. The resistance value is generally not too small, at about 100 ohms. If the resistance value is too small, the heating will be serious and the temperature will be higher. Each 100 ohms resistor forms a closed circuit with a string of electric cells. Let's take the ternary lithium battery as an example. The single-string equalizing opening voltage is about 4 volts. According to the formula, the passive equalizing current flowing through the lithium battery is about 40 mA. Active equalization is to actively transfer the power of high voltage strings to low voltage strings to achieve the overall voltage consistency. At present, there are three main ways adopted: capacitive equalization, inductive equalization, and the transformer equalization. The working principle of the capacitive type and inductive type are the same. For example, there are 24 strings of cells. The voltage of the first string is high and the 24 strings is low. This equalization method is to transfer the extra power of the first string to the second string, and then transfer the second string to the third string, and so on, and finally make up the voltage of a 24th string. The difference between the two equalization methods is that the capacitive type is relatively simple. Only one chip is used to control the entire equalization process, and the equalization current is also small. The inductive type has one chip in each string, and the battery pack is 24 strings has 24 chips. The equalization process is completed by these chips incorporation. In this way, the overall circuit design and operation will be relatively complex, and the equalizing current will also be large. Different from the above two, transformer type equalized adopts an overall solution. For example, like these 24 strings of cells, if the voltage of the last string is low, the chip will calculate the amount of voltage to be added. Then, the other 23 strings will share it together. Each string will provide 1/23 of the voltage of the equalizer for the string. And similarly, if the voltage of the first string is high, the chip will divide the voltage that needs to be reduced into 23 parts and then distributed to each string of cells. This method has higher requirements for software and hardware, and of course, the equalization effect is also better. With the development of science and technology, we hope that lithium batteries will become better and better, and more problems will be solved. Okay, this is the end of today. If you think our video is helpful, like and subs appreciated. See you on the next video. Bye.